Okay, we're in the fourth section of chapter 2, functions. We're going to determine whether a correspondence is a function and use function notation. Find the domain of a function and write a function that relates to quantities in application form. So first of all, what is a function? A function is a relationship between two variables such that each value of the first is paired with only one of the second. And the domain of a function is all the possible values in the first variable, and the range is all the possible values in the second. So here it's saying 1 is being assigned to 10, 2 is being assigned to 11, and 3 is being assigned to 12. We don't know how they're related, but that's how they're related. So according to the definition, it's a relationship between two variables, yes, such that each value of the first is paired with only one value of the second. Yeah, that's a function. Here, they're all going to 10. That's okay. That's a function. As long as 1 is always going to 10, and that's okay. If you're telling me 1 goes to 10 and then 1 goes to 30, well, which one is it? They can all go to the same place. Here, you're telling me 1 goes to 5, you're telling me 3 goes to 6, but now they're saying 3 goes to 7. Well, does 3 go to 6 or does 3 go to 7? So because of that, it's not a function. Students still get confused, so I try to do something like this class. So say I have all of you guys in the computer, and the computer has you as your name, but really it's programmed like you are a number. So say you're Mike. What are you scheduled for for Monday at 4:40? You're scheduled for Math 22. Same with Ashley. And same with Joe. You're all being scheduled for Math 22. The computer would allow that to happen. Just like you see 10, 10, 10, you see Math 22 3 times. And the computer would assign each person to the same output. That's okay. But if the computer had Mike going to Math 22, and then the computer had Mike going to Math 21, well, he'd be assigned to 2 different classes, and that is not possible. The computer would error, and it would say domain error, meaning that this domain, there was an error. You're assigning it to 2 different variables. Okay, so that's how you decide if it's a function. Example 2 says, let A equal ABC, and let B contain 1, 2, 3, 4, 5. Which of the following sets of ordered pairs or figures represents a function? Well, they're taking an element here and assigning it to an element here. They're taking an element here and assigning it to an element here. And they're taking an element here and assigning it to an element here. So yes, that is a function. Here, they're taking an element from here to here and here to here. Well, that's what we did last time, but they're not using all the elements. It'd be like saying, here's all the students in our math class. They were all being assigned to this class or another class. This is saying, oh, we're only gonna use this student and this student. What about poor student C? Okay, they didn't use all of their domain, so it's not a function. They left out some people. Okay, just trying to personify it so it makes a little more sense. Okay, what about C and D now? Now, if you also are like, and want to read more about it, these I just take directly from your textbook. So you can look at the examples more in the textbook. This one, you have A, B, and C, and they're all going to 1. And here you have A, B, and C, and they're going to all different numbers here. So this is a function. One's a function and one's not. So let's think about this. We said we had to use everything in the domain. We do, in both. It says A goes to 1, B goes to 1, and C goes to 1. That's fine. That's like all of our kids going to Math 22. However, what's not fine here is you're saying the student goes to 1, and then this student also goes to 2, or this domain variable is being assigned to 2 different outputs. That's not possible. So that's not a function. Okay. Here it says you can use the vertical line test to determine if a graph represents a function. So if I create a vertical line, I have a coordinate where there's only one output. There's only one output, only one output, only one output. Here, if I use the vertical line test and I get 2 outputs, that means it's not a function. You're telling me 2 goes to 2, and then you're telling me 2 goes to -2. That's not possible, so it's just not a function. Okay, determine whether each equation represents a function of x. So the best way to do this is to get y by itself and then just draw a general sketch of what the function would look like. So y is not by itself. We have to get rid of this -2. So we're going to add 2 to both sides. So now you're telling me x squared plus 2. What would that graph look like? If you didn't know what that graph would look like, plug in points. I suggest plugging in -3, -2, -1, 0, 1, 2, and 3. If I plug in -3, I'm going to get 9 plus 2, which is 11. If I plug in -2, I'm going to get 4 plus 2, which is 6. -1, it's going to end up being 3. If I put in 1, I get 3. Oh, this looks very familiar. It's going to end up being a parabola. X squared plus 2, so it's a parabola up 2 units. Does this pass the vertical line test? Yes. This one, I'd get y by itself, but I already know if you have an x squared plus y squared, that's actually a circle. So this is an equation of a circle. So it's just like, it's going to be kind of hard when you do homework if you don't understand some of these graphs, but we can go over them and discuss them. I'm not going to make it crazy on your test, okay? If you have a circle and you graph it, yeah, it won't pass the vertical line test, so not a function. Okay, here is just how do you evaluate functions. So normally you would see this as you are starting out algebra. Y equals. Well, it's a little more professional and a little more mature to write, this is my function of the variable x. I like this because you can plug in the number and then you automatically see the output. It's like you have a coordinate pair, which when you plug in the number for x, you just see y. So this one's saying it's not using f. They decided to spice it up and use g. You can do whatever letter you want. You can say h of x, m of x, g of a, g of b. It doesn't matter, okay? Well, this is g of 2. So that means in my function, wherever I see a 2, I am going to put it here. And whenever I remove x, I replace it with parentheses. The reason I do that is people are going to get confused with a negative in exponents. So let's start here. Please excuse my dear Aunt Sally. Exponents comes first. So you're going to still have that negative. So it's going to be -4 plus 8 plus 1. So it's going to be -4 plus 9. So your answer is -5. So g of 2, when I put in 2, I get -5. Okay, that's Algebra 1, Algebra 2 review. G of t, it's saying wherever I see an x, I'm going to replace it with t. So -t squared plus 4t plus 1. It's fine. That's it. I'm going to replace x now with an entire quantity, x plus 2. So wherever you see an x, replace it with x plus 2. If you left it like this, fine, but I'm sure other professors would like you to simplify as much as possible, especially if it's multiple choice and your answer isn't this option. So you're going to expand. When something is squared, it's something times itself. I'm going to distribute this. Then I'm going to FOIL these two first before I bring in the negative. X squared, 2x plus 2x plus 4. Oops. 2 condense those two. Then I'm going to bring in the negative. This is going to be 4x, so it's going to be negative 4x. Bring in the negative the whole way. The 4x's are going to cancel each other out to be 0. And then the negative 4 and the 12 are going to be 8. That's your answer. Okay, take your time with these. If you think you know what you're doing in some of these, always just pause the video, try it on your own, and come back. You'll learn a lot more that way. All right, piecewise functions. You're using a piece of a function. So this function contains two different equations depending on your situation. So I always tell students it's like taxes. You go in, and depending on where you're at or how much money you made that year, you use a different equation for your taxes. So if you're less than 0, you use this equation. If you're greater than 0, you're going to use that equation. So here they want to know when x is negative 1, when x is negative 2, or I'm sorry, 0, and when it's 1. Okay, so when it's negative 1, that is less than 0. So you're going to use this function. Negative 1 squared plus 1. So it's 1 plus 1, which is 2. When f is 0, well, you can only use this when you're less than 0 or greater than 0. So it does not exist. D and E does not exist. All right, what about if you're the number 1? If you're 1, then you are greater than 0. So it's going to be 1 minus 1, which is 0. Okay. All right, finding the domain of each function. Here, your domain is just your x values. So if it repeats, just write it once. And try to do it in numerical order. So we are negative 3, negative 1, 0, 2, and 4. And then here, they just want domain. Domain, if they don't give you just coordinates like this, you have to think about it logically. Okay, domain is all real numbers usually, except where can it go wrong? So here I have division. Where in division are there boo-boos? Are there errors? When we divide by 0. So when we divide by 0 in mathematics, that's when we're gonna have errors. I can be any number, but I don't want this to turn into 0. When will this turn into a 0? When will this equal 0? When x is negative 5. So you stop and you say, all right, it can be any number, but when can this go wrong? Well, I see division. I can't divide by 0. When will this be 0? When it's negative 5. So your domain is all real numbers. X cannot be negative 5. Another way to write all real numbers is to say negative infinity to infinity. You don't have to. All right, here, volume. Okay, think about volume, all real numbers. Except, oops, there's a little thing. It should be pi r cubed. With volume, can volume ever be negative? No. So volume, the radius has to be positive or 0. So we just say r has to be greater than 0. So otherwise you won't have anything. All right, square roots. Can you take the square root of any number? You can take the square root of positive numbers, like the square root of 25. Can you take the square root of 0? Yeah. Can you take the square root of negative 25? No. So this can't be a negative. Not x, but this whole thing cannot turn into a negative because you can't take a negative of a square root. So it has to be greater than or equal to 0. Well, divide by negative. Then bring it over to the other side. So your critical numbers are 2 and negative 2, because I'm going to factor this. So if you have a bunch of numbers, a lot of you were doing this in your 1.6 or 1.7 homework, I can't remember. This is your smallest number. So your intervals are from negative infinity to negative 2. Your next interval is from negative 2 to 2. And your last interval is from 2 to infinity. A lot of you are just putting these numbers and then jumping to the answer. That's not the answer. You have to show all the intervals and show how you got it. What's the number between -2 and 2? 0. Will that work? If I put 0 in here, it'll work. So it's probably just this interval and not the other one. Okay. Let's try one here. Let's try the number 3. If I put 3 in here, it'd be 9, and that won't work. So your answer is between -2 and 2. All right, and we have brackets because you can equal 0. Here, can you take the cube root of a negative number? Yeah. Positive number? Yeah. 0. So could I take the cube root of 27? Mm-hmm. Cube root of 0? Mm-hmm. Cube root of a negative number? Yes. -3 times -3 times -3 is -27. And if you're like, how would you even know that? You just got to ask yourself, this is all right until what happens? Where is there going to be a downfall? Okay? And the whole goal is to have this done and your homework done so that you can ask those questions. So some of you need to get on it. All right, email me your questions. I'll see you next class.